formula, writing the chemical formulas. Okay, so I tell you the simplest way for the writing the chemical formulas from its names. Okay, so here we start. We need to know the periodic table first. Means in the periodic table, sorry, consists of two types of the groups. One are called normal elements, which have almost fixed oxidation states, as you can say fixed valencies, and oxidation states. Okay, you must remember it. And second is called transition elements. Transition elements have the issue that their oxidation states keep on changing. So, but in the names when will be given, so it will be mentioned that the iron, it has two valency or three valency. Okay, so they have variable oxidation states, variable valencies, you can say, are oxidation states. But from the names, we'll get the full information that what is the oxidation state or the valency of the elements from the transition. So what is the ionic compound? Ionic compound, now ionic compound is the ionic compound which is made up of the cations and anions, means the ionic compound which contains the ions. So it must have the cation, which has plus charge, okay, and anion. And you must know that these have opposite charges and they attract each other, okay? They attract each other. So due to the electrostatic force of attraction, what we call it? Yes, there becomes ionic bond, okay? Suppose we have example Na, it has cation, it is plus, and Cl, it has minus, okay? So cation and anion. So there is an electrostatic force of attraction between the cation and anion. So when they combine, so an ionic compound is formed that is called NaCl, means the triple salt. Okay. So before we start, we need to know the periodic table. Okay. Periodic table. First is hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Second day is called beryllium, magnesium, calcium, strontium, barium, and radium. Okay, you'll have to memorize them. In different languages, their mnemonics have been given. So mnemonics for them in the Punjabi and in the Urdu are different, but in the English it will be different. So for those who are from the Asia, they understand it. Hali ne ki rab se faryad, badi maj ka sar bada. And here will be the transition elements. There are 10 groups of the transition elements. Then we'll start this third day. That is Baba means boron. Ali, Gaya, India, Thailand. Okay. In this way, this is a short trick. You can memorize it easily. Next is fourth thing. That is Sassi Gai Sindh Punjab. That is the fifth thing. Nation Pakistan Assi Sab Bhai. Means nitrogen, phosphorus, arsenic, bismuth, and the tin and the bismuth. Okay. And the sixth day is OCC2. Okay, they have their own specific names, but here we are just writing their symbols. To memorize the symbols, we use the Asian language, that is the Punjabi or Urdu, you can say, they can easily understand. But you will find their mnemonics from your own language, okay? Seventh is Fahim cleaning bathroom in Attak. And eighth is, which are called noble gases. Hali ने और कराए X-ray. So remember that these are the noble gases. These are why these are called noble gases, because they do not react. Okay, or you can also call them inert gases. So all other elements try to become like noble gases. Why? Because it is stable and these are the stables and they do not react. So how can they become like the noble gases? They can become like noble gases by gaining and losing electron, means by gaining octet electronic configuration, duplet or octet electronic configuration. Having 2 electrons in the outermost shell, duplet. Having 8 electrons in the outermost shell, octet. So they have 1 electron, and to become octet, they have to gain a 7, 1 plus 7, 8, or they have to lose 1. So inner will be octet. So in this way, they prefer to lose 1 electron. So that's why by losing electron, they gain the +1 charge. They have 2 electrons in the valence shell, and to become octet, valence shell means the outermost shell. Inner is complete. Inner has the 8 electrons. Okay. To become octet, they need to gain the 6 electrons and to lose the 2 electrons. So for them, losing 2 electrons is an easy job. So they lose 2 electrons, they gain the +2 charge. Okay. They have 3 electrons for becoming like the noble gases by gaining octet electron configuration. They also have to gain how many electrons? 5 electrons. 3 plus 5, 8. But they don't do it. Why? Because it is difficult job. So they prefer to lose 3 electrons. So it becomes +3. They have +3 charge. Okay. So next is carbon. They mostly share. They form the covalent bonds. Okay. Nitrogen. Sometimes they form means they have 5 electrons, and to become octet, it's difficult to lose 5 electrons and easy to gain 3 electrons. So that's why they gain 3 electrons and they become -3. Sometimes, mostly they also share. They both of them mostly take part in sharing. Okay, but sometimes nitrogen can also be anion. Okay, means by gaining electrons. Phosphorus too. They have 6 electrons, and for becoming air, they have to gain 2 electrons. They have 7 electrons, and for gaining air, they have to lose 1 electron. So they become anions, means which have the negative charges. They do not react because they're already stable. They become anions and they become cations. Okay. So you must know that ionic compounds have no charge. I mean, these are the neutral. Ionic compounds are neutral. These are neutrals. How they are neutral? Because of the same, or you can say equal plus and negative charge. It means equal positive and negative charges. How they gain positive and negative charges? So here is the main formula that we are going to study. Suppose we have to make sodium chloride. How would we know that sodium requires 1 chlorine to become sodium chloride? Now let's see this formula. Na, it has plus charge. Chlorine, it has minus charge. There is cross. First, we have to write the cation and anion with their charges. The first step is. Okay. Second thing we want to know means with the charges. Okay. And the second thing is we want to know how many atoms will be required for making their ionic compound. So here is minus means -1. So here we bring downward till here. So it is -1. We remove the minus, we skip the minus, we just write here 1. Here is the sodium, it has +1. So we bring here down to this. This is called cross extend method. In their charges are brought to the down bottom right side of the other ions, you can say, of cation to anion and of anion to cation, but without charges. So it means sodium requires 1 atom and chlorine also requires 1 atom. So it becomes NaCl. Now NaCl is a neutral. Okay. And this is the good component. So the same we can find. If we have to found the magnesium chloride, then okay. We practice here. Okay. So next is Magnesium chloride, okay? So we have found the space. Magnesium has which charge? I study right now +2 charge, okay? Because they lose like 2 electrons, +2. And chlorine has -1 charge, is minus charge. Cross exchange method 2 here 1. So it becomes MgCl2. Now it is neutral. Means magnesium has +2 charge, chlorine has -1 charge, but its two atoms become -2. So +2, -2 cancel each other and it will be neutral. Same, if we have to make aluminium chloride, aluminium +3 charge, chlorine has minus charge. Okay. 3, 1. Become aluminium chloride, AlCl3. Aluminium has +3 charge, so chlorine has -1 charge, multiply 3, it becomes -3. +3, -3 cancel each other and it will be neutral. So let's make one more to understand it. Means you must remember that first is cation and the second is anion. Okay, means first should have the cation and other must be the anion. Aluminium oxide we wanna make. Aluminium has +3 charge, oxygen has -2 charge. We do the cross exchange method. 3, 2, it becomes Al2O3. This is aluminium oxide. Okay, it is neutral. So the same process or the same procedure will be used. You can see here some compounds, some are the cations and anions, which I have told you, okay, but some are the molecular cations. When molecule loses electrons, it become molecular cations, and some are molecular anions. So we need to know their charges. Okay, sorry, this is not going correct. So molecular cations are a few, means ammonium NH4, it has plus charge. Next is hydronium H3O plus charge, but it is rarely used. Mostly this is used. Okay. While the molecular anions are many more. Nitrate NO3 minus charge, sulfate SO4 -2 charge, carbonate CO3 -2 charge, phosphate PO4 -3 charge, bicarbonate HCO3 minus, bisulfate HSO4 minus, and the same way some will be next. Bicarbonate, if we have bisulfate, is we have biphosphate as HSO4 -2, it will become. So these are some molecular anions, and we have to memorize their charges, their formulas, and the charges as well. Okay, so because they can also be used, but this is all about the, means the metals lose electrons to become the cations, and the non-metals gain electrons to become anions. Okay, this is all about it. What about the transition elements? Transition elements do not have variable accelerations, do not have fixed acceleration states, they have variable. So with their names, it is given that what is their acceleration state. For example, ferrous chloride. What this shows? This shows that it has +2 charge. Okay. Or ferric chloride +3 charge. So let's begin. Let's start practicing. Here have been given some valencies and symbols, and I have told you already their charges. Okay. Sodium chloride, you know that Na has plus charge, chlorine has minus charge. By the cross exchange method, one here, it becomes NaCl. Is it okay? Next is sodium hydroxide. Na has plus charge, hydroxide OH has minus charge. By cross exchange method, we bring to the right bottom of other ion It has plus charge 1 plus 1, so it becomes NaOH. Okay. Next is sodium carbonate. This is the complex thing. Means we know that sodium is Na plus charge. Carbonate CO3 has -2 charge. We bring by the cross-section method. Here will be 1 without charges. Here will be 2. So it becomes Na2. CO3 will be just once. Why? Here you can see that it will be neutral. Means sodium has plus charge. So by its two atoms, it becomes +2. And carbonate, its single molecular anion has -2 charge. So +2 charge of these two atoms and -2 charge of this single molecular anion, and -2 +2 cancel each other, and this ionic compound will be neutral, and this is the correct. Okay. By using this method, we can solve many. Means magnesium chloride I have told, potassium nitrate. K, it has plus charge. Nitrate NO3, it has minus charge. So 1 and 1, it becomes KNO3. Magnesium hydroxide. Let's solve it. Magnesium has +2 charge. Hydroxide OH has minus charge. Let's bring by cross-section method to the bottom of other 2 and 1 times. So magnesium, but this OH, if I write here 2 like this, so it means just 2 atoms of hydrogen, not of oxygen. But if I take in the bracket, so it means OH 2 times. This is the correct way. Okay, when we have in multiple times, so we write here like this. Suppose we have some type of calcium oxide. Okay, calcium has +2 charge. Oxygen has -2 charge. So when we bring here 2, 2, so they simplify each other, and it becomes calcium oxide like this. Barium sulfate, aluminum chloride, we have studied. Aluminum oxide, we have done it. Aluminum hydroxide. Okay. Aluminum sulfate, this is the important one. Aluminum, it has +3 charge. Sulfate SO4, it has -2 charge. By cross-section method, it becomes 3, it becomes 2. So I will have to write here Al2. It's okay. It's showing that aluminum 2 times. But here SO4 -2, how many times? 3 times. But if I write here 3 like this, so it becomes only oxygen becomes 43 times. So to write this 3 times, I will take it in the bracket and I'll write SO4 thrice. Now you'll see it's neutral. How? +3 charge of aluminum multiplied 2. It's 3 checking. +6. -2 charge of sulfate and multiplied 3 times. -6. So it will be 0. It is neutral. Okay. All the ionic compounds are neutral. Okay, because they are cation and the anions have the equal charges, and we have to balance by this cross-section method their charges, and then that ionic compound is okay. First we have to write cation and then then anion. Okay. Now we have the copper. Copper actually belongs to the transition elements. Okay. So copper has which charge? +2 charge. Why? How do we know? It may vary, but it has been mentioned here that it has a +2 charge, and sulfate SO4, it has -2 charge. So what we'll do? Correction 2 times by simplifying 1 time. So CuSO4 simply will write here. Now we study copper nitrate. Okay. Copper nitrate. Cu +2 charge. It has been told that it has +2 charge. Nitrate, it NO3 1 times. So it is 2 times, it is 1 time. So it becomes copper. But to write the nitrate NO3, what we'll do? We'll take it in the bracket. Okay. Silver, we know that Ag has +1 charge, and bromide, it has minus charge. 1, 1, AgBr. But here we have lead oxide. Eb has plus which charge? +4. Okay. First is always cation. Second is always anion. And oxide means oxygen. Oxygen has -2 charge. 4 times and 2 times. By simplifying 1 times and 2 times, so it becomes PbO2. lead oxide. Iron sulfate for this Fe plus 3. It has been mentioned here. Sulfate SO4 minus 2. By cross inverted 2 and this is 3. So Fe2, but SO4 to write 3 times, we will take it in the bracket and Fe2SO4 thrice. This is the ionic. This is the correct one. So in this way you can practice, and the remainings which I left, those are actually for you to practice. Okay, you may pause the video while watching it, and you can practice yourself. And as many times you practice, you will understand well. Okay. Thanks. Take care. See you in the next video.